Just a few announcements, and then we will um, move on to our last day on variation problems. Um, We have one other section before our next test. I think we can cover that in one day. So the plan is we'll do variations today. And then it's called waves. It's using the sine function. We'll do that tomorrow. On Thursday, you would have a review assignment. And then Friday and Monday, I will give class time to do the test. You would still need to log in on Monday for attendance. It would be a good chance if you had any questions, you could ask them on Monday next week. Otherwise, it just frees up a little bit of time. I know some of you have assignments that you're working on, some past assignments. So you can think of it as a way to make up some of that work, which is great. Um, and if you're caught up, then it's just a great day to catch your breath. So that's the plan kind of moving forward this week and into next week. And as you can tell, probably by looking at your book, we're almost done with this book, which is awesome. So we will keep moving forward. All right, so last week we talked about direct variation on Thursday and inverse variation on Friday. So today we're going to talk about combined variation. I'm going to remove this because joint variation is a specific combined variation. So a combined variation is simply a variation that, I should say, an equation that contains more than one variation. So for example, Z varies directly with X and inversely with Y. And so if we wrote that out, Z would be equal to KX divided by Y. The joint variation, you'll see it's defined in the textbook in one of the problems. It just means that we have direct variation with multiple variables. So that's why it's technically not it's a combined variation, but it's a specific combined variation. All right, so problems might look like this. For the following example, Z varies directly with X and inversely with Y. Find X when X equals 6 and Y equals 2, Z is equal to 15. Find Z when X is 4 and Y is 9. When we had direct variation or inverse variation separately, we could find those pretty straightforward. If it was direct variation, we could use proportions. And if it was inverse variation, we could multiply. Now that we have combined variations, it's going to be a little bit different. So I'm going to start with the equation. Z varies directly with X and inversely with Y. And we're going to use the first values to solve for K. So 15 for Z, 6X over 2. I'm sorry, 6K over 2. That looks like a K almost. So 15 would equal 5K. K is equal to 3. Knowing that K is 3, we can go back and solve for any of the other variables if we know 2 of the values. So in this case, I want to find Z when X is 4 and Y is 9. So it's basically plugging in what we know, solving for a variable. And then taking that information and plugging into the equation to solve for a different variable. So in this case, Z is 4/3. And again, you will have problems in your homework. Some will look just like this. Others will be word problems. So here we have a wonderful word problem. The maximum load a cylindrical column can support varies directly with the 4th power of the diameter and inversely as the square of the height. A column that is 2 feet in diameter and 10 feet high can support up to 6 tons. If a column is 1 foot in diameter and 12 feet high, what is the maximum load it can support? I am going to give you a minute to write. So go ahead and take your time to do that. I'll get attendance taken while you do that. All right, hopefully that was enough time. If not, unmute yourself and yell at me. So the maximum load, maybe L, that a cylindrical column can support varies directly with the 4th power of the diameter and inversely as the square of the height. So using the first bit of information, we know that 6 tons can be supported by 2 to the 4th over 10 squared. And one thing you want to make sure of is that the units going from one part of the problem to the next are the same. So our diameter and our height are in feet in both, so we're in good shape. We can go ahead. We don't have to worry about converting units. So 6 is equal to, let's see, 2 to the 4th, 2, 4, 8, 16 K over 100. $600 equals 16 K. Excuse me. Go ahead and divide this out. So K would be 37.5. So we want to find then the load where the diameter is 1. So we have 37.5 times 1 to the 4th over 12 squared. And I don't know, round this to a couple decimal places. This would be about 0.26 tons. If you don't like the tons and wanted to go with pounds, you could multiply that by 2,000. It would be about 521 pounds. Because the original was in tons, I would probably just go with the consistent label there. All right, homework. So again, I'm assuming we'll be at the test review Thursday, and then the test. I'll give you a couple of periods to work on that, but make sure you do check in for attendance on Monday.